Here today we're going to be looking at Leetcode 26, remove duplicates from sorted array. We're told that we're given an integer array nums sorted in non-decreasing order, which is basically ascending order, and we need to remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same, and then we need to return the number of unique elements in nums. And the number of unique elements is denoted as k, so we need to return k. We're given what the judge to test our solution is, but this isn't the most accepted. This isn't the most important thing to look at. The most important thing we'll probably look at is the examples. So in this example here, we're given 1, 1, and 2. So we should return k equals 2 because the first two elements, 1 and 2, are the unique elements. In this example here, we return k5 because the unique elements in the respective order is 0, 1, in the respective ascending order is 0, 1, 2, 3, and 4. And the elements that come after k number of elements doesn't matter. So any remaining elements of nums are not important, as well as the size of nums. So these numbers here aren't important. It's just the first k elements which are important. So the way we can solve this problem is by looking at each element having 2 pointers. So we're going to have one pointer which will go through which will do a pass through our list, and another pointer set to the first element of our list. And the reason we want it to be had at this first element of our list is because we want to do a comparison with the previous element. So I'll kind of explain. So in this example, you've got 0. Well, if we start the first element, we say, is 0 equal to the previous element? Yes. So we know we don't have any unique elements. The next element is 1. Is 1 equal to 0? No, it's not. It's a unique element. So we replace 0 with 1 because this is where our left pointer is, and we make the left pointer, we increment the left pointer to its new position. Then we look at the next element. Is 1 equal to 1? Yes, it is. Okay. So we haven't found another unique element. We go to the next element. Again, it's 1. The next element after that is 2. Is 2 equal to 1? No. So 2 is a unique element in our list. And so we can put it back at the value 1, so position 2, which is where our left pointer is. And we'll keep doing this until our function, until we finish off passing through the list, and then we'll just return k, which will conveniently be our left pointer. So I think it may make more sense if I actually code this up. Let's set our left pointer to 1, and let's have our right pointer. We'll use a for loop instead of a while loop just because it's slightly easier. So we'll say for are in range of length nums. We'll say if nums r does not equal the numbers of r minus 1. So if the number that we're currently at isn't equal to the previous element before it, then we know we found a unique new element. So in this example, if we've got the element 2, well, 2 is not equal to the previous element 1, so we know we found a new unique element. So we could say nums at the left pointer is going to be equal to nums of r, and we'll increment our left pointer by 1, and we don't need to increment our right pointer because our for loop is doing this for us. So the last thing we need to do now is return L, which again is conveniently going to be it's going to be k, so the number of unique elements in the list. So let's run the code. 1, 1, 2. Oh, we need to start off from the first position for the pointer r as well. So we were starting from 0, we need to start from 1. Okay, looks like we passed both test cases. Let's submit our solution now. And again, we pass all 362 test cases. So looking at the time complexity, we're looking at a linear time complexity. It's just a single pass. So it's O of n time complexity, and space complexity is going to be constant, so it's going to be O of 1 space complexity. So I hope this solution made sense and that you guys enjoyed the video, and I'll catch you in the next one.